Good morning to all of you. Welcome to my class. Before starting the class, we tell you that this chapter, that is the complex number, is most important and most easiest chapter in mathematics due to various point of view like JEE, CEE, and Ncert and other state board also. Let us start today's class. Second class on complex number. We discuss conjugate and modulus. What is the conjugate? Let z is equal to x plus iy be a complex number. Now, conjugate means if a complex number z is equal to x plus iy, if we replace this I by minus I, then we get its conjugate. Generally, conjugate is denoted by z bar. Z bar. Z bar equal to what? That means we have since replaced I by minus I, then we get x minus iy. This is the conjugate of this complex number. That is z is equal to x plus iy. Z bar is equal to x minus iy. Generally, conjugate is denoted by z bar. Conjugate is denoted by z bar. There are many properties in conjugate and complex number. Number one property, we have to know this property. Number one property, z bar is equal to what? Modulus z square. Very important property. Z bar means if we multiply this and this, then we get z bar is equal to what? X plus iy whole into x minus iy. This equal to what? A square minus iy whole square. This implies x square minus I square y square. This implies x square. I square is minus 1, therefore minus minus plus, therefore y square. Also, what is modulus z? Mod of z. Mod z is nothing but mod z is equal to what? Under root real part square plus imaginary part square. What is the real part of z? Real part of z is equal to x, therefore x square plus what is the imaginary part of z? Imaginary part of z is equal to y, so y square. If we squaring both sides, then we get what? X square plus y square. Therefore, from here and here, we can say that z bar is equal to modulus z square. That is the very important properties of conjugate. That is z bar is equal to z. This is very easy to prove. Suppose we consider z is equal to what? Z is equal to x plus iy. Therefore, this implies z bar equal to what? X minus iy by definition of conjugate. Therefore, again we take z bar, again bar, then we get I replaced by minus I, then we get what? Plus I. This equal to what? Z bar equal to z. Next property, z1 plus z2 bar is equal to z1 bar plus z2 bar. Number property 3, z1 minus z2 whole bar is equal to z1 bar minus z2 bar. Similarly, z1 into z2 whole bar equal to z1 bar into z2 bar. Similar case in case of division also, z1 by z2 whole bar equal to z1 bar divided by z2 bar, where z2 is not equal to 0. And number 6 property, z1 bar modulus of z1 bar is equal to modulus of z. Why? Z equal to what? Z is equal to x plus iy. If we take modulus of z, then we get what? X square plus y square. What is z bar? Z bar equal to what? X minus iy. Therefore, modulus z bar equal to what? Root over x square plus minus y whole square is equal to what? Under root x square plus y square. What is this? This equal to what? Z. So you can say modulus of z bar is modulus of z. That is z inverse. That is inverse of z, which is written as z to the power minus. That is known as a multiplicative inverse. That means z is a complex number. Their multiplicative inverse is how we get z bar divided by modulus z whole square. Then where z is not equal to 0, in this way you can find the multiplicative inverse of z. And similarly, number 8 is equal to z to the power n whole bar is equal to z bar whole to the power n. Very important properties. These are the very important property of conjugate complex number. You should remember this, by which you can put many type of complex numbers problems. We are going to discuss modulus. What is the modulus? Let z is equal to x plus iy is a complex number. Modulus, what is modulus? Modulus is denoted by modulus of z, mod z. Mod z is always positive. And that is the distance of z from the point of point O, origin. That means this equal to what? This equal to x square plus y square. Is the distance, so it is a positive. We take only positive value of this. It represents the distance from O to z. This can be written as what? That is the real part of z square plus imaginary part of z square. That is known as the real part of z square, that is x, and imaginary part of z is equal to imaginary part of z square. So we can write this mode of z equal to what? X is under root of x square plus y square. Like an example, suppose we take z is equal to what? 3 plus 4i. Then what is z? Mode of z equal to what? Under root 3 square plus 4 square. This is equal to what? 9 plus 16. This is equal to what? 25. That is the mode of z of the complex number 3 plus 4i. Similarly, in case minus also, z is equal to what? Take 3 minus 4i. This implies mode of z equal to what? Take z is equal to this, then we get what? Under root 3 square plus minus 4 square is equal to what? Under root 25 is equal to what? 5. From here we can say that this is the conjugate of this number. Therefore we can say that mode of z is equal to z. That is the module. To discuss the properties of modulus. That is first property, mode of z equal to mode of minus. Suppose z equal to what? X plus iy. This implies mode z equal to what? Under root x square plus y square. Therefore, minus z equal to what? Minus x minus iy. This implies minus mode of minus z equal to what? Under root of minus x square plus minus y square. This is equal to what? X square plus y square. So we can say that mode of z is equal to mode of minus z. Next, mod of z equal to 0. This implies z equal to 0. That means mod of z, z is equal to complex number. Therefore, mod of z is equal to what? X square plus y square under z. And that is the positive quantity. This also positive. This also positive. This means we can say this, if we squaring this, then we got mod of z is equal to what? X square plus y square. This equal to 0 and this is equal to 0. Therefore, if this equal to 0, that means this is equal to 0. X square plus y square is equal to what? 0. This is only possible when x is equal to 0 and y is equal to 0. That means we can say that z is equal to what? X plus iy. This is equal to 0 plus I into 0 plus I into 0. That means 0. If this equal to 0, that means we can say z equal to 0. Next property, mod of z1 into z2 is equal to mod of z1 into mod of z2. Similarly, mod of z1 divided by z2 mod, this equal to mod of z1 divided by mod of z2. And this property is a very important property, that mod of z to the power n is equal to mod of z whole to the power n. This also prove easily. Other proofs also we can prove it easily, but no need of proof here. But you have to remember this property. Suppose this, in case of we say that z cubed, this equal to what? Z into z into z. This equal to what? By this property we can say that z modulus z. This equal to what? Mod of z whole cube. Therefore, we get z mod of z cube is equal to what? Mod of z whole cube. Similarly, we can say that mod of z to the power n is equal to mod of z whole to the power n. We can say this. Now, one thing is a very important point in case of complex number. That means we can say, suppose 1 plus thrice I and 4 plus twice I. Who is greater and who is less? In case of complex number, greater than and less than we cannot say. That means in case of complex number, less than and greater than is meaningless. No need to compare. That means we cannot compare two complex number. There is a meaningless. That means less than and greater than in case of complex number is meaningless. And another very important point is under root of a into under root of b is equal to what? A b in case of positive real numbers. Positive real numbers. If a and b are negative real numbers, then this is not satisfied. If a is a negative and b is a negative, then that rule is failed. A very important point. In case of this is real positive, then we use this rule. But if a is, that means we can say negative a into negative b is not equal to root a. Very important. We are going to discuss some important problems based on conjugate and modulus and imaginary numbers. Problem is this: I to the power 18 plus 1 by I whole to the power 25 whole to the power 3 is equal to what? Solutions. We can say that I to the power 18 means I to the power 16 equal to 1 into I square. That means we get minus 1. Okay, that is we get minus 1. Plus 1 by I is equal to what? Already we have discussed 1 by I is equal to minus I. Therefore, we can write here minus I whole to the power 25 whole to the power what? 3. This is equal to, we get minus 1 plus I to the minus I to the power 24 is equal to what? 1. Therefore, we get 1 into minus I whole to the power 3. Why? Minus I whole to the power 24 is a multiple of 4, so we get what? 1. This is equal to, we get minus, again minus I whole to the power 3. This we take consider common, then we get 1 plus I whole cube. This equal to what? Minus 1. That is 1 plus I square is minus 1. No, that is 1. Therefore, plus 3 into 1 square into I plus 3 into 1 into I square plus I cubed. This equal to what? Minus 1. 1 plus 5 side is equal to minus 1 minus 3. This equal to what? I cube is equal to minus I. This means I cube is equal to what? Minus I. This equal to, we get minus twice I minus 2. This implies 2 minus twice I is the result. Next question is a very important question. That is, if A, B, C are complex number, very important point, such that A plus B plus C is equal to 0. Also, mode of A is equal to mode of B is equal to mode of C equal to 1. Then we have to find 1 by A plus 1 by B, 1 by C equal to what? This problem is based on conjugate and modulus. Solutions. Since we are given that A plus B plus C is equal to 0. If we take conjugate of this number, then A plus B plus C bar is equal to what? 0 bar. 0 bar means what? 0. This can be written as by formula A bar plus B bar plus C bar is equal to what? 0. Again, we are given that mode of A is equal to 1, mode of B equal to 1, mode of C equal to 1. But we know that Z bar is equal to mode of Z square. If mode of Z is equal to given 1, that means we can say Z bar is equal to 1 square, that means 1. So we get Z bar equal to 1, who is a condition of unimodular. In case of Z is a unimodular, that means mode of Z is equal to 1, then we can say that Z is a unimodular number, complex number. Therefore, from here we can say that Z bar equal to what? 1 by Z. Or we can say Z equal to what? 1 by Z bar. And that is the very important points. Here also we can say that A bar is equal to what? 1 by A, since A is a unimodular. And similarly, B bar equal to what? 1 by B. Similarly, C bar equal to what? 1 by C. That is the conditions getting from unimodular, from here. Therefore, we can write here A bar is equal to what? 1 by A. B bar equal to 1 by B. C bar equal to what? 1 by C. This equal to what? This equal to 0. That is the result. Next question is, this question also based on conjugate and modulus. Here, if Z1 is equal to 2 and Z1 is equal to 1, Z1 is equal to 2 and Z2 is equal to 1. That is 2, sorry. 2 is equal to 1 and Z1 plus Z2 is equal to 3. Then find mode of 4 Z2 plus Z1. Solution. We know Z bar is equal to mode of Z square. Here Z1 is equal to Therefore, we get Z1 bar is equal to mod of Z1 square. This is equal to what? 4. Therefore, we can say Z1 is equal to 4 by Z1 bar. Similarly, Z2 is a unimodular. Therefore, we can say Z2 is equal to what? 1 by Z2 bar. Since we are given that Z1 plus Z2 mod is equal to what? 3. This can be written as Z1 equal to what? 4 by Z1 plus Z2 is equal to what? 1 by Z2 bar. This equal to what? 3. If we take LCM, then this implies we get mod of Z1 bar, Z2 bar, 4 Z2 bar plus Z1 bar. This is equal to what? Mod of Z1 bar into mod of Z2 bar, and this is equal to mod of 4 Z2 bar plus Z1 bar. This is equal to, you can write down this Z4 Z2 plus Z1 whole bar by Z1 plus Z2 whole bar equal to Z1 bar plus Z2 bar. Here also we can write this is equal to Z1 mod Z2 mod. Since we know that Z bar is equal to mod of Z, this is another condition. This is equal to given, this equal to what? 3. This equal to 3, this also equal to 3. Next, can say mod of this equal to what? Mod of this equal to same thing. Therefore, 4 Z2 plus Z1 like this. This is equal to by this equal to what? 2 and 3. Therefore, 2 into 1, this equal to 6. This implies we can say 4 Z2 plus Z1 equal to what? 6. We are going to discuss very important problem based on conjugate and modulus. The question is, if alpha and beta are the different complex number with mod of beta equal to 1, then find beta minus alpha divided by 1 minus alpha bar beta whole mod. Solution. Mod of beta minus alpha by 1 minus alpha bar beta. This is equal to, if we multiply numerator and denominator by beta bar, then we get beta minus alpha beta bar divided by 1 minus alpha bar beta into beta bar. Very most important step you have to remember it. After this is equal to, we get beta minus alpha into beta bar mod divided by beta bar minus alpha bar beta bar modulus. But we know that given beta bar equal to 1, beta not bar, mod of beta is equal to 1. We know beta bar is equal to mod of beta square. This implies beta bar is equal to 1 square is equal to 1. Therefore, we get beta bar equal to 1. Also, we know the mode of z equal to mode of z bar. Here, mode of beta is equal to mode of beta bar. Since this is 1, therefore this is equal to 1. So, mode of beta bar equal to 1. Now, put it, then we get mode of beta minus alpha into 1 divided by beta bar minus alpha bar into 1. This is equal to mode of beta minus alpha divided by this is equal to right beta minus alpha whole bar. Since mode of z is equal to mode of z bar like this. Since this is equal to z1 plus z2 bar minus is equal to z1 bar minus z2 bar. Now this is equal to, we can write mode of beta minus alpha. This equal to, we can write beta minus alpha. Since z mode of z is equal to mode of z bar, so beta minus alpha bar is equal to beta minus alpha mode. Therefore, this is the same. This equal to 1. Therefore, we get this is equal to 1. Please share and subscribe the channel to get new lecture on the topics complex number, which will be helpful for JEE and other state board, Assam Higher Secondary Education Councils and CBLC also. With good wishes all of you. Thank you.